Competition for oxygen. So this is back to displacement reactions, really. A more reactive metal will displace a less reactive metal from its oxide. This even happens in the solid state. And the driving force behind it is the idea that the more reactive metal will form a more stable oxide. So go back to your energy level diagrams. Basically, the bonds that are being made are much stronger than the bonds that are being broken. First example is iron and copper 2 oxide. Let's have a look at the overall equation. Iron displaces the copper from the oxide to make iron oxide and copper metal. What's been oxidized in this reaction? Have a think about that for a second. What's losing electrons? Which of the oxidation states is increasing? Well, it's clear that the iron here is losing electrons to make Fe2+, and the copper is Cu2+ here is gaining electrons to become copper metal again. So it's a redox reaction, this displacement reaction. It's a very similar reaction, slightly more spectacular, and I'll show you the video in a second, is a reaction between zinc and copper oxide. Same idea. The zinc displaces the copper. So which of the two is oxidized? Zinc is oxidized to Zn2+, losing 2 electrons in the process, and copper is reduced to copper metal, gaining 2 electrons. You can watch this particular process happening if you click on the link to the video there or here. The Thermit process is another good example of displacement in the solid state. So here, aluminium, a grey metal, is mixed with a lovely red powder. It's this iron 3 oxide. When they react, the aluminium forms aluminium oxide, but liquid iron is formed. The temperature is so high that liquid iron is formed. Here we need to do a bit of balancing, so have a look at the balancing. Yeah, you need 2 and 2, don't you? Delta H is very negative. It's a very exothermic reaction. In all of the reactions, heat is needed to start the reaction, and then a large amount of heat energy is produced, and that makes the reaction proceed rapidly. The thermite process, or the Thermit process, produces so much heat energy that molten iron is made, and you can use it to repair railway tracks in situ, in the place. This you can have a look at here on this video. You can also see us do this reaction in the laboratory by clicking on this link. In solution, very similar thing happens, not quite as spectacular, and you've seen this lots of times. Zinc will displace copper from copper sulfate solution to make zinc sulfate and copper metal. The ionic equation, getting rid of which ions are the spectator ions? The sulfate ions are the spectator ions, they don't change. This is the reaction that's taking place. Obviously, you've got oxidation of the zinc, losing 2 electrons, and reduction of the copper, gaining 2 electrons. What would you see here? You'd see this is a grey metal going into a blue solution. And what happens is the solution, because zinc ions go into solution and copper ions come out of solution, the solution starts to lose its blue color, and a pink metal, a pink precipitate can be appreciated. another reminder that the reactive metal in these reactions is always acting as the reducing agent. The reactive metal is giving up electrons and reducing the other thing. A little bit of revision from year 10, just to remind you, when you put two metals in a circuit, in this case in dilute sulfuric acid as an electrolyte, you can get a voltage produced. And the bigger the voltage, the bigger the difference in the reactivity of the two metals, the larger the voltage produced. Zinc and copper produce 1.1 volts, for example. Now the electrons here, the zinc goes into solution and its electrons go around the circuit. Conventional current goes in the opposite direction to electrons. So that makes this cell, in this cell, copper is the positive pole and zinc is the negative pole. Again, looking for universal statements about these things. The more reactive metal is always the negative pole, and the less reactive metal is the positive pole in a cell. Right, plenty of questions from essential chemistry for you to try there.